Learning focus. In previous lesson, we have discussed Newton's second law of motion. When a net force is applied on an object, the acceleration of the object is directly proportional to the net force and inversely proportional to the mass of the object. From Newton's second law, we deduce the equation F equal to ma. We have also discussed friction, where we learned that friction exerts on an object is not affected by its speed of motion. In previous lesson, we also discussed Newton's third law of motion and what is normal reaction and tension. In this lesson, we will discuss impulse, including its formula. We will also discuss impulsive force, its formula and applications of impulsive force. Last but not least, we will discuss the safety features of vehicles. Impulse. Impulse is defined as the product of the force acting on an object and the time of action. In the equation, we write impulse equal to F times t, where F is the force exerted on an object and t is how long the time the force applied on the object. When a non-zero net force is applied on an object, it will cause the momentum of the object to change. The amount of impulse exerted on an object is equal to the amount of momentum change of the object. In the equation, we write impulse equals mv minus mu, where mv is the final momentum and mu is the initial momentum. Final momentum minus initial momentum means momentum change. Well, since momentum is a vector quantity and impulse is equal to momentum change, therefore impulse is a vector quantity. Impulse versus force. Another thing that you need to know is the difference between impulse and force. Impulse causes velocity change. The greater the impulse, the greater the velocity change. A force causes acceleration. The greater the force, the greater the acceleration. Acceleration is a measure of how fast a velocity change. In other words, the greater the force, the faster the velocity change. In short, an impulse determines how much velocity change, whereas a force determines how fast the velocity change. Example 1. Let's look at this example. A car of mass 600 kg is moving at a velocity of 30 meters per second. A net force of 200 Newton is applied on the car for 15 seconds. Find the impulse exerted on the car and hence determine the final velocity of the car. Well, let's list down all the informations that we have. The mass of the car is 600 kg. The velocity of the car is 30 meters per second. The force acted on the car is 200 Newton. And the time interval the force acts on the car is 15 seconds. We are asked to find the impulse and the final velocity. Let's see what the formula of impulse. Impulse is equal to F times t or mv minus mu. We have F and t. Therefore, we choose I equal to F times t. Plug in the value of F and t. The impulse is equal to 3000 Newton second. Don't forget to write the unit. Okay. The second question is, how much is the final velocity? We have mass and the initial velocity. We also know the impulse. Therefore, we can use I equal to mv minus mu to solve our problem. Plug in I, m and u. Move this to the other side. 3000 plus 18,000 equals to 600V. Hence, V equals to 21,000 over 600, which is equal to 35 meters per second. This is the final answer that we want.